Alright, number 6, we have log base 1/4 of 16, and we want to know what that equals. Again, without a calculator. So equals x. Remember that little circular method. Okay. So I'm going to have 1/4 raised to the x equals 16. Okay. And we can rewrite 16 as a base 4. This is 4 squared, so we have 1/4x is equal to 4 squared. Now, since 4 is on the bottom, I want this to be on the bottom. So if we had a negative, okay, remember, this is anything on the bottom. We could write this as having a power. We could say a -1, okay. And in order to move that up, it's a positive power. But anyway, to move it in the opposite location, you just change the sign of the exponent. So this 4 can come up. So I'll have 1 times 4 to the -1 power. And this is to the x. So I end up with 4 to the -x. So difference here, -x equals 2. Or furthermore, if we divide by -1, we get x equals -2. So a negative second power will give us the solution here. So -2. Alright, number 7. This time we actually have the answer, so we'll just solve it. We have log base 27 of x equals 2/3. So same thing, the base raised to the answer equals what we're taking the log of. So we have 27 raised to the 2/3 power equals x. Now what this means is the 27 is raised to the second power, the 3 is the root. So if I write this as a radical, this will be the cube root, the bottom number goes in the root, 27 squared. Now we can do the cube root of 27. I like to make it smaller first. 3 times 3 times 3 is 27. Okay. So the cube root of 27 is 3. So we get 3, and then we have 3 squared. 3 squared equals 9. Okay, so x is equal to 9. Just by taking the root first. Now you can square 27, it's going to give you a really big number, and then you might need a calculator to solve that. It doesn't say to do it without a calculator, but if you are familiar with some of those powers, the smaller powers, you can do it without it. So x equals 9.